Thank you all for being here. I'd like to thank INCIBE for creating this cyber camp once again, so that we can share some days speaking about cybersecurity. Let's begin with my talk. You've seen the title. It's low-cost Stingrays, which are also known as IMSI Catchers. I've already been introduced. My name is Pedro Candel. I'm known as Soren, the eye that sees everything. This nickname was created by some students of mine because I caught them cheating. I like cybersecurity and I've been working in this for a while. This is our agenda. We'll have a short introduction, which is the basis. Very often we want things to work, but we haven't understood concepts. For example, a few days ago I received a private telegram from a student that has seen part of my project, and he wanted to use his mobile phone. And he thought that in 5 minutes, 10 minutes, he was going to be able to do it. He realized, when I explained the basis, he realized that we should start from scratch. We have to invest a lot of effort there. Then we're going to see Stingrays, some commercial products. There are many, they're marketed. We're going to see a low-cost device, a very simple one. The problems I've faced. We're going to speak about jammers to inhibit signals and how we can do so that these jammers, which are low-cost devices, and then an IMSI Catcher, which is fully interactive, that would do everything automatically. Without further ado, let's review our basic concepts. 101. I don't want to get into detail here, but we need to know the upper part. What's an international mobile subscriber identifier, or IMSI Catcher? This is a device which we're going to install wherever we want, and it's going to act between the telephone towers and the phones we carry around on our pockets, everywhere. This is a description which comes from Wikipedia. It says that it's a fake mobile tower. For new technologies, we need to fake the signals. But be careful, this is illegal. We have no license or authorization whatsoever to do this. We can have lots of problems. But I'll explain what we're going to do. And then there are attacks. Perhaps 3G, 4G, 5G, once it comes into existence, but we could downgrade the frequency bands, leave things as they worked in the past. GSM technology, for example, I don't think anyone still uses it. Then in the demos, we'll see whether it's used or not, and we'll see the myths and realities we have. As I've said, we have two types. IMSI Catcher, which is passive. That's just for receiving radioelectric spectrum. We install it, and it emits a series of things everywhere, such as TV signal. You install your device, and you listen the messages. Unfortunately, if we analyze the messages, we'll realize that there are data which could compromise ourselves, but it's like exposing the national identity document of our phone. And then there are active devices that emit. This is fully illegal. Even in the passive devices, we have a situation of lack of legality, absence of legality, so to speak. For those of us who are radio amateurs, we can listen to a series of bands, but we should not disclose the content of the messages. But we're not injecting signals. A dummer is injecting signals, which is also illegal, but perhaps we go to the cinema and perhaps there are signal inhibitors, which of course are working so that mobile phones do not ring. They're scanning the frequencies so that you can watch your film. This is the myth we have. Yeah, the classical van in the middle with an antenna. And all the people involved in this. This seemed like a film, and no one would be surprised at saying something similar to this. If we see this, we applaud and say, great. It's nice that they're here to offer better coverage, and a fare to call, to receive messages, etc. I'm saying this because we've been told that there are cars such as these ones. Pictures have been taken, but today you don't need big devices to do this type of things. So you can hide it. We're going to speak about SIM. You'll know about this. It's the card provided by the carrier. It has a master file. There's a system of files, and within this file system we are offered the IMSI. This is the ID that identifies this with this card and our terminal with regards to the carrier we have hired. The IMSI, as I've explained, it's a 15-digit number, and the telephone carrier, in order to avoid duplicates, for example, it's exclusive for each device. Store them and send it securely. In other words, if it could compromise you, if it's linked to your mobile phone, it should be sent securely. And of course, it's linked to any type of network, GPRS, UMTS, 3G, LTE, among many others. And when 5G comes along, we'll use it also. Compensation. There are the mobile country code, 3 digits, and of course, wherever we travel, we know we have roaming services, and the operator, the telephone carriers from other countries will identify where we come from. Within the countries, we have the mobile network code, since there are different carriers. We have 3 digits in EMEA region, for example. Then we have the mobile subscriber identification number with 9 or 10 digits. And the purpose of all this is that altogether we have 15 digits. There are a series of 80 commands. When we used modems, we used them. There are 1,000 ways of knowing the IMSI we have. We can write 80 plus CIMI and then we know it. I've made a reference here to 80 commands. We had which has lots of interesting commands. Another project which is ATCMD, which will allow us to send lots of commands to research or to search baseband. And once you get into this, you get amazed at the number of things that you can do. As I've said, these are the 15 digits, and in the case of Spain, all of them begin with 214. And then its provider, its carrier, you may have a T, O, whichever letter that identifies the carrier, and then they distribute the rest of the digits for each of their customers.
Then we also have the IMEI, which is a number identifying the equipment. It's well, some people may think that IMEI number does something else or other than identifying the equipment. So when we lose our device, we report it, and then IMEI number is checked. Well, connection, I just don't want to dwell on it. And this is an initial connection that gives the mobile device a temporary code known as TIMSE. So, and then TMSI is used to identify the device every time we want to connect to the mobile network. And TMSI number is generated as the phone is being restarted, because the original IMSI cannot be transmitted. And as I say, TMSI is used to check the identity of the subscriber. And how do I know that you are who you are claiming to be? So carriers have kind of a number of blocks or gadgets to do that. Here we will have an HLR, home location register, and VLR, visitor location register. And this code through the IMSI obtain detailed information which has been stored in HLR and VLR. And so that the data identification IMSI code is not obtained, IMSI is used instead. However, sometimes I can use the information stored in my SIM card. VLR is responsible for locating the device, and it would assign a TMSI code accordingly. Who's got access to that? Well, carriers have access to our location. For instance, when a person is missing, when information is asked from the carrier is asked to give the TMSI data to find out about the latest steps, kind of well, given by or taken by the missing person. The device stores TMSI information, data, etc. So my website, well, you may access it. Now it's under construction. You can go back to it. So hopefully in a couple of days I will start this. I will restore my website so that you can access this information. So therefore I will not go through it now. So we should know that we have software such as AIMSI providing us with information about the device, the location, as well as network information, and as well as the unique data to the of the antenna we are connected to. And it also tells us about the identifier, mobile country code, and mobile network code. And then, well, this data? Well, the mobile telephone is aware of this data. Carrier also has this data. However, what I don't like is someone to stand in the middle and to retrieve that information. So this is one of the systems. And well, this is a more complicated graph of what we have, of what we are using nowadays. No matter the access, the way we access. So this has been presented in a conference. So there are very many experts in this field, and also very much experts in attacks to carriers. I will be talking about IMSI Catchers, but sometimes carriers are being attacked and all that is compromised. And sometimes we see that more than once we've been seeing that we are in a vulnerable situation. And well, other than being vulnerable, we have a number of off-the-shelf products. Well, one of them is known as Piranha. Piranha, through an RSDI, it becomes an IMSI Catcher. Then we have a Sprinter. That is a system off the shelf that we can buy. They would ask us whether we are private detective or law enforcement agencies, or we are just wrongdoers who want to buy these type of devices. So this was one of the first out in the market. And then we have another site, for instance, Soggy. Soggy is a manufacturer. We are more afraid or frightened here because he's got a number of products that, as he says, his product can gain access even to our data traffic in the network, as you may see there. So this product can gain access to some functions. Notice they claim to have access to intercepting HTTPS. For instance, to intercept traffic flow in Facebook, Twitter, Skype, etc. In terms of price, we are talking about a high amount of money. We are talking about active, complete systems with a price of 6 million euros. Governments are, of course, interested in having this type of systems, and some researchers may also be interested in having this type of systems. But we, because we are more humble, okay, and we do not have that financial capability, we will try to do that at a low cost. So we've been talking about SDRs for years now. And what are SDRs? Well, SDR is just a dongle that we buy just to watch TV channels. So it comes with an antenna by design, an antenna such as this one. And I guess that all of us carry one of these antennas with us in our rucksack. Some of these antennas are more powerful than others. But here, this dongle is 2832U. So this is the frequency range. The frequency range goes from 24 to 1766 megahertz. Within the radioelectric spectrum, this is the frequency that they work in. The cost is extremely low. This is around 12 euros, 15 euros. because they became really trendy and were used for many more things, well, the price has increased significantly, but anyway, they are available in any stores, and these are a number of modifications and changes that we can make with them. We may use a number of converters to down convert some signals, or up converting low signals. However, well, the crystals they have are not high quality, but still they are a good way to start to take the first steps without spending high amount of money. And then we have Oros 42 project from IMSI Catcher. I saw that project and I said, why not? It's really cool. Actually, I saw it in Twitter. So right away, you can catch all the IMSIs and the GSM band. And then this is what you need. It says on the site, you need a PC, and I say you need like one USB, and I say, well, I have it all, and this is the setup. And I said, well, if I have 15 minutes, okay, I will just play around with it, and I will do it, and I start to monitor things. Notice it took like no time to do it. And now we get to the actual installation. Well, we thought it would be, well, 15 minutes. We had to do that, we had to do that, we had to do that, installing all that, and last, downloading the actual project to be ready to go. And also you have seen the GNU radio. GNU radio takes long time. So the same for Raspberries. You may go and say, well, this will take 10 minutes. No, it's never that short. Well, you take your time, and well, if you want to replicate it, well, it will take you at least 48 hours, a full weekend. So this is how it works. Through a Python script, we will just introduce the IMSI Catcher, then GSM Live Mon. So within the GSM band, and then also the SDR device that we will be using. If we are talking about 3G and 4G, we should not forget that the maximum frequency was 1766, but if I am at 2600 megahertz, I would never reach that frequency, no matter how much I do. And as I say, well, we may have up converters that we can play around with, but we will soon realize that we will need significant sampling, and we also need a highly accurate synchronization of the crystal. Then we will soon realize that that will not be helpful. But when it comes to GMS and having a good time, this is good enough. And we also have Wireshark to monitor all the GSM tap, and that is to say, well, to start walking. And now I'd like to show you a demo. I didn't show you this antenna. You can see that it has a spiral in it. This is for a different frequency bands, and again, you don't need big antenna. That antenna will be okay for 3G, 4G, and the 2600 frequency band. And then regarding SDRs, well, this is of a higher quality. And now the demo. Well, apologies for that technical delay. All right, we'll just plug in a USB. And I will be following the steps. I'm running it, I'm viewing it. I will run it in a specific frequency. And I did my homework before, and I've seen that this frequency range, this is the same as in TV. In Malaga, we have frequency ranges assigned or given out to each of the carriers, and those frequency ranges may differ from those in Madrid or somewhere else. And this is what we should be aware of. And this is another typical antenna. I'm sure you are familiar with it. Well, this is not necessary, but still, I just want to show it to you. And now we are seeing the GNU radio. It's starting to receive signal. And it decodes this signal. This code is very simple. So this is identifying the carrier. And then the famous 214 that I mentioned before, 21404. So, well, in theory, you should not be seeing it, okay? It is your imagination who is seeing that. All right? What else could we do with that? Notice this is GSM. We said before that, well, GSM is not used anymore. But who has his mobile phone blocked so that you only operate in 4G? Well, we don't do that because we just want our mobile phone to switch network as available. So we just don't want to. We just want to do that for the sake of convenience. So, for instance, the taxi drivers, when they take out the point of sale payment device, and then they log on to a GSM network, and you say, oh, they are sending in data from my credit card. Well, some of those communications are encrypted through a protocol, but still, well, that protocol may have been broken since the day it was invented. So you download Rainbow and you decode everything, any information that is going through it. For instance, voice, where we have a number of control channels asking you to go there, to go somewhere else. And then in this case, with our SDR, we gain access to a small sample. We only have 2 megahertz of bandwidth, so that is 2 million of samples per second, and that would not be enough, okay? So I haven't wasted my time in checking and in monitoring or tracking all that. However, if we were to use other type of gadgets available, we could track much more than that very easily. So what could we do with the information that we are seeing on the screen? So White Shark is now running. So we have GSM tap. So we are dissecting the protocol. So I'm within GSM. I don't know whether you can see that or not, but if I type in LAC, this is a filter. That is location area code. means that each of the cells is sending it the DNI and is sending it its parameters. So if you are monitoring that cell and if you are seeing the IMSIs in that cell, you are seeing who is connected there. But if you go somewhere else and monitor another cell and you can see that this person here is also connecting to that very same cell, well, that gives me a hint. So this is the cell identity. So each of the mobile towers, when we come out to the street, we see they are just ordinary mobile towers. This would allow us to see the cell identity, and actually we could even locate it. And here we have the location area identification. We see who is allotted to, or frequency allotted to. So Spain, France Telecom, and for that specific cell. Okay, I will stop that. No longer necessary. Alright, I don't want to go anything illegal. Alright, I stop that and I move on with the presentation. So we have already been successful at seeing something at least. So I was talking about 2G. And what happens with LTE? There is a paper there that we all follow. This compiles research carried out by other people, and that paper says that despite common assumptions, method of reality, unfortunately, LTE of IMSI is always transmitted in the clear at least once. Well, whenever relevant conditions are in place. And in this case, we can use another SDR. And this SDR gadget is it's more expensive. The previous antenna was 10 euros, whereas this gadget could be 600, 700 euros. But still not very expensive compared to the 6 million euros that we mentioned before. And this time we are talking about an LTE base station. We could also jam that frequency, that channel, and then convert it into GSM, which is what we know how to do. But I said, well, we have already, well, that is already explained in the paper. The only thing we have to do is to follow it and to reproduce it. And I can assure you that it works. So this is how connection with the node is being made. And then when we place, well, a fake, our telephone does not distinguish it. The same as Wi-Fi. When a fake is introduced, well, right away we will log on there. Well, the same goes with the telephone. Telephone connects to the most powerful network just to save battery, so it cannot really differentiate whether it is authentic or fake. And for a long time now, we've been trying to see whether we can detect fakes or not. I remember once in Madrid, There were rumors about some of these gadgets being around Gran Via Street. So this allows us to extract IMSI from the messages. The problem is that to set that up, you need to emit. And because I cannot emit, sorry, I cannot show you a demo. Sorry for that. This is IMSI Capture, no problem. And this continues to evolve. This is from 2018. The previous one that I showed you was from 2 years ago. As I said, this is quite new, more recent paper, but it tells us about the vulnerabilities. So he repeated because we knew about the vulnerabilities. These vulnerabilities are repeated or show again. So here we have right on top identity requests, and now we also have service reject. And as I say, we continue to see a vulnerability there that would allow us to catch IMSI, no problem. What are the problems that we have found? Well, Linux as well as our gadgets so far posed several problems. I was saying that I am at specific frequency. For instance, before I used 926 megahertz. But if I want to go to a different frequency, 900 or over 900, I need a different gadget. But if I want the 928, what do I need? I need another gadget. As you can easily imagine a TV. Imagine that you want to watch all the TV stations simultaneously. Well, what do you need? Well, you will need several TV sets and to have channel tuned in each of the TV sets. So that kernel doesn't get confused and knows how to differentiate the various devices that we are using. We should write down those rules so that we can connect several devices, so that different devices listen, and so that we can guide or lead the various projects to point them at different devices, the 0, 1, 2, etc. Then imagine a device who is using access. No, we just want a headless one. If I am aware of the frequency, having or working on headless mode is enough. And then we move on to frequency, we move on to calibration. And here we soon realize that we need higher quality devices. Often I talk about blades. These are SDRs. And it's actually a prototypical one for me to do JAMA. This is well, one of the most typical ones. We have also others, and the cost is around 6,000 euros. So this is 6,000 euros, a really nice device with a high sampling rate. And then we can catch GPS signal. And there are things that you could never do with a 10 euro device. And then, well, also working with very many LTEs. Well, this could be good for some type of spoofing. We could do that, but we are taking risks. We are already emitting, and remember that this is forbidden. So now we go back to the paper from 2016. What happens when there is a location leak? Yes, the thing is that this device could be tracked. So it's just finding out where it is connected to. If I get to a location, or if I make triangulation, which is a very simple mathematical calculation, you wouldn't really know about the exact location, but you would know whether the person is closer to here, far away to here, or I don't know, the person is, I don't know, just traveling. And now we move on to jammers, which are signal inhibitors.
Pues da las referencias.
I always like to give you the references. Here, they were part from 2015. In this case, a jammer, and they said frequency range 800 to 2700 per output. If we understand what it says, it's too much, and it allows you these bands: GSM 900, GPS, or GSM 1100. We'll see where it is now, the providers we have, the operators we have in Spain. And it tells us the bandwidth we need, 25, 20, 15, in order to jam and inject noise with power. This is what I've explained before. Regarding HackRF, the bandwidth we get with HackRF is 20 megahertz. I can inject noise if I want. It's not exact. You can inject noise occupying 20 megahertz. With BladeRF is 28, and with the others it's even more. What can we do? On the one hand, we could use a selective SDR. There's a project I love, which is Modbot Map, which recovers information from 2G, 3G and 4G cells with a mobile device. I was going to say you use Samsung, but because several, I use Samsung. I connect the cable and receive the information. We choose the carrier automatically or manually, and we can select the channel. After that, we make it work, and it tells you everything. Frequencies. Of course, we want to know where they are. And we can check where the frequencies are. And here, any country in the world, this is regulated. That's why we can't emit. And therefore, we have the national scheme of frequency attribution. That's why we had to change TDTs when there was that mess. And for cells, we have a project which is called Cell Mapper that allows us to identify where they are. This is very easy. This is 2G. GSM scanner, it's going to tell you where they work. And for ADT, you just have to come here and it identifies everything. Here you see the results. This is what we have for a specific carrier. In this case, it starts with the letter M or T, whatever you want to call it. These are the nodes they have here. And you access number of frequencies, bands we're using for GSM, UMTS, LTE. In LTE, band 3, which is 1800 plus. And you can test, play, identify, but one channel. Another one, and then with the device, this is the information you get in downlink frequency. Maybe we want to inject noise. Therefore, a non-selective SDR can find the frequencies we want to cancel. We estimate the central frequency. I want this and this one. I estimate the central frequency. You have bandwidth. I inject noise. We generate Gaussian noise. In this case, with 20 megahertz, a generator with regular GR. We put it, here we have the frequency, we estimate it, we make it work. This is what I did. I'm not going to lie to you. I went to a shop, Chinese-owned shop, to look for a portable fridge to use it as a Faraday box, because I'm not allowed to emit. This was the result. We managed to leave it outside. The mobile is not left outside. If we're cancelling 4G signal, it goes to 3G. If we cancel 3G, it goes to GSM, which is the situation we had years ago. Protocols which are broken. What are we doing? We are using open source, a device, something you just plug and play, that implements the passive and active part. It's modular. It includes jammer. It has databases, can be controlled remotely, low cost. But that, like this, huge hardware. Manufacturer that starts with E. And maybe, so far, we'll see this with the Men in Black. We may open the project so that everyone uses it, or each person, knowing the basis, you can do it for yourself. It's not complicated. This was a prototype. So that you can see how it works. I'm going to show it. Let's see. I'll enlarge it.
Uno, dos, tres, cuatro, cinco, seis, siete, ocho.
1, 2, 3, 4, 5, 6, 7, 8. This is the gadget. We press start, and of course, no device. You need to connect this. I'm going to do this with it since it's low cost. It's recognized the device, low cost. This is the information. And now, what can we do? We can scan, etc. But we should look for the cells. We press here. And what's behind this? We're mapping not just Malaga, but we may have requests from everywhere. We search the cells in order to speed up the process. This is GSM, just GSM, and it takes a very long time, but we combine this with the frequencies we've observed, with the information we've crawled. Here it detects these two data that we had before, and in this case this is Madrid, this is mobile. going to make it smaller, but not that much. Since we're in Malaga, that would be where we are. And here, these are the cells the device has detected. This usually depends on the IP we have. Familiar. I walk around a while ago and I saw it. Here, when it's pinpointed, I didn't get closer to this, but this one at the bottom, you see it. If you go out to your right, you'll see it repeated with 3 antennae, which is what we are receiving. So this is for this carrier, and if we combine this, this is HTTPS, this is from another project. You insert the data and it shows where it is. It shows everything. What am I interested in? What do we want now? I want to scan. If I want to scan something else, I insert other device or whatever. I press and I receive the information. What do we have here? Databases with IMSIs and the people there are. And just in case, we have integrated different queries to HLR records. Some providers, some carriers give you the IMSI just like that. Why don't we check it? If you know the mobile phone and you can check the IMSI, you know this is from this person and it means that he or she is here. So we could search and we could check. If you want to try with your phone to see the data we receive, any volunteer? Conti, you need to come up to write it. I'm going to use my number so that we don't have any problem, because sometimes I've linked a name I wasn't supposed to. This is information. It's going to carry out a query to a consultation server. Can you see it? Yes. Here. And the data here, the IMSI is telling me 214.0354. That's not my IMSI. This is a public server. And then we would have SSMCs and cells where you are. Some of them fail, some provide those numbers in the same query. What I'm going to do is using some things that are open out there, that are properly secured. I'm going to ask it to mix all the information And it says we're here. This could be more precise, but I haven't mapped each of the towers we have in the province. But that's enough. Well, what's this? When we use the active part, we combine with this for GSM. I've been listening to this frequency of this other. It configures virtually everything automatically so that you can also have GPRS. I'm sure you want data, you want your IP address, your voice service, and absolutely everything. And we even have the call record, and this allows you to cross data. And you can do many more things. This is what I can tell you. I would like to thank you. And we open the Q&A. Do you have any question? I'll be around, so you can ask me things later. I just wanted to know whether you know of a good book to learn about mobile networks. There's echo, I cannot hear. Do you know about any book in order to know more about mobile networks and all this? Book about mobile networks? Yes. There are many. The publishing house, Chema's publishing house. You have Layek's book on telecommunications, €20.22. Ayak, David, Jose Pico, both brothers. It's very good. Anyway, I would like to strongly recommend you that if you're interested in this topic, you should read the papers, but do not install any hardware until you understand what the papers say, because otherwise you're going to waste your time, big time. Because you see how things work, because we have done it, because we've already been there, we've already wasted our time. And it was not just little time. And now cars, motorcycles, and many devices are using GSM. Why? I guess they have cheap contract to have data transmission real time. What band do they use, and how do you identify it, if you can identify it? The cars, motorcycles, the devices that are already used. A car, yes. For example, the carriers that for IoT, they have a SIM so that they connect to networks, and they send everything. That SIM and that carrier is registered, because otherwise they wouldn't be able to operate. But here, there's a problem. Carriers are safe, but if there's another place which isn't connected to them and they fail, well, it's complex. And identifying to which we're exactly connected, well, what do I want to say? I would like to thank you. I would like to say that if you want to learn, follow his page. Thank you was quite a gift once it's up and running. I hope Monday, Tuesday, if you can, you should follow him, because it's among the top ones, not just in Spain, but also in the world. Conte loves me a lot. He's been my teacher. And there are many things we can learn from him. And thank you very much. He's just opened his website. He didn't have a website until very recently. I would like to thank you all for being here and putting up with me. Thank you. Well, this is it.